Welcome back to Death Toll Racing. We're building a Rogue 625 tubing bender today, the cart, and we're going to modify it. We're going to do some stuff. Then we're going to test it, and we're going to see what it can do. Max capacity on this is 2-inch quarter wall, so we're going to do that, and we're going to make sure it can do what it says it can do. We are going to add a little bit to it so that it's going to be a little stronger than the way they sent it. Not that it wouldn't have done that anyway, but I always like to overkill everything. So follow along. This is a really fun project. All right, so the first thing I did is I used my tri-square and I just centered this plate exactly centered on our tubing. This would normally be channel if you're building it the way they were building it. And then it should line up with this edge. As far as I can tell, everything should line up there. What I'm gonna do first is tack this plate to this tube on both of these corners because I want to make sure everything is square before we commit to it, and that'll give it a nice spot to pivot around. And then we'll center these up and make sure our ears and everything are real square. They stay pretty square because there is these Legos, so the Legos hold it. So they're going to be pretty close, but it's possible they're tipped a little bit like that. So we want to make sure everything's kind of straight and even before we proceed. Okay, so I tacked it right at the edge of all their little welding indents. Tacked the Legos, I tacked the front of the ear, and then the bottom back corner of the ear, and then I tacked the tube to that plate, or that's actually a piece of channel. And now we should be able to flip it over. Okay, so there was a flat bar that goes in across here, and then this guy that goes on the end. There's nothing really locking that square, so use your square on your flat surface. If you don't have a really flat surface, you can just square it off of the tube, or in your case, channel if you're using channel. So the next step, there's the Lego here, that slides in there, and then you line up, there's an inside edge right there. You just line up, easier to see that one. So now we're just gonna double check that these plates are parallel the entire way. They should be, but we wanna double check that. But that did seem to hold it nice and square off of the main plate down there. We haven't done any welding yet, we're just tacking. We're going to tack all the way through. We don't want to start welding and warping anything before we get this thing all the way together. All right, so we're already about ready to start welding. So we are going to be testing out our little Vulcan welder. I don't suspect this is going to be too much for that welder, but we will see. A couple things I want to point out. On here, you'll just weld these divots. They call for a 1-5 skip. That means there's 1 inch for every 5 inches of material. So it's a 1 skip 4 or 1 skip 4. So if we were to measure those, that's what they should measure, assuming they know. Well, looks like they got it at a 1 inch weld. They got it about a 1 4.5, but that's just probably so it spaces that evenly. I wouldn't worry too much about that. So then when we get to these, there's a little bit to do on our wheels. On ours being a 625, the only thing we need to weld on are these, which are just a sticker protector. Then it's pretty much assembly after that. So pretty easy stuff. It calls for a 1/2 inch of weld around here, which is a little bit excessive considering this is so thin, but we'll do it. And then down here would be pretty critical to have weld. Again, they call for 1/2 inch weld. That's a lot of weld. That's mostly you're using a weld as a gusset more than anything else. In that situation, since you're only welding to 1/8 inch plate on here, and then you're welding to 1/8 inch channel here. So take our time. We don't want to warp this thing. I put a couple of spreader bars on just to try to keep these as straight as possible as we weld. Those aren't going to hold way up here for down here. So if we do a ton of weld on the inside and not an equal amount of weld on the outside, it's going to pull in. So we want to be very, very even on our welding, but a nice 1/4 inch bead along here will be good enough. So that's all we're going to do. And then we're going to skip around as we do it, always countering each weld with another weld. So if we weld on this side, we're going to immediately weld on this side. Weld on this side, we're going to immediately weld on this side. And we're not going to just weld the whole thing in one pass. We're going to do a section, weld the opposite side, blah, 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 the whole way through. So I'm going to make sure that everything is tacked up real good on this thing, and then we'll start welding. One more thing I wanted to point out. This is actually labeled front, if you can see that. Which means that that orientation of those holes is supposed to be pointing this way. So as it's upside down, the upper hole is to this side. But it also says front, and this is the front of the machine. It's pretty much the side of the machine you stand on. Everything stayed where I wanted. The only thing I did really different than what they said is I didn't put as big of a weld on these ears. So generally speaking, you don't put welds on bigger than the material you're welding to. So if this is 1/4 inch, quarter. Unfortunately, it's only 1/8, and so is that tube. So I don't really see too much benefit in doing bigger welds there. The only thing that they would do is kind of act as a gusset for this rolling one way or the other. So if we see a lot of deflection and stuff while we're using it, we will. Oh, I can add more weld, but I don't want to over weld something that doesn't necessarily need to be welded that much. It's already quite a bit over welded. The weld isn't the weak part of that joint. That would be all this stuff. So I'm pretty sure that's going to be good enough, and we will again just watch it. If it looks like it needs reinforcement, we'll reinforce it. So turned out pretty good. It's not too bad. Easy welding project. Everything stayed straight. That's thanks to, oops, I just stepped on my TIG torch, my pedal. So the only thing I TIG welded, and the only reason I did is I just wanted to weld this along there. And I'm not the best TIG welder in the world, but I got it done. Just so that this is welded, the 1/8 inch plate is welded to that channel there. I didn't really want to MIG weld that and try to prep it up into there. Had I thought of it beforehand, I could have prepped this plate so that we could have welded with MIG, but I didn't think of it, so I just did what I did. All right, so I don't know if I assume you just saw me cut that off, but I had it on backwards. I'm not really sure why this is there. I'm not going to do anything about it now, but I have a feeling I'm going to cut that off. I don't want that. That's going to be like right at your knee, the bottom part of your kneecap, and I don't think I want those things there. They don't do anything. I can just cut them off right here. The die just sits on this roller there, like that. So maybe it's a shield, so if you were to push this up against something, it hits like the wall before the dies hit the wall and roll them off. But I'll just be careful with it. I don't want that thing sticking out. Probably, but we'll see. I'll get it a little farther along before I commit to that. Kind of my thought process here. So I am going to place this thing permanently on this cart. That may require me at some point in the future to have to cut this part out. I can't think of a situation where that happens. As this thing rolls, the tubing comes up and around. So what would have to happen for that to be in the way is I would have to have an already 90-degree bend, beyond 90-degree bend, in the tubing, and then if I wanted to bend it the opposite way, so it would be going in at an angle that way and hitting, and then bend it the other way. That is not a very likely scenario. But I want this thing as rigid as possible, so I am adding, I want to make it permanent to this table so everything kind of works together and makes it rigid. And then for some more cosmetic rigidity, I'm going to add gussets down the side, and then I'm going to add these gussets in these corners. They shouldn't interfere with anything as far as function, but I think it's going to make it look a lot cooler. And then on here, we're going to add these guys. So these ones actually may function a little bit because this is probably the main area of load on this whole assembly. So the more you can distribute that forces out to other places, the better. It's not very heavy, but it distributes some, takes some of the load off everything, keeps that thing straight, so it should work. These, I don't think they do anything, but cosmetic rigidity is always a plus. And then those, 100% cosmetic rigidity. I don't think those are going to do a damn thing, but they're going to look cool. So, you know, it is what it is. But those are some pretty cool gussets. I designed those myself. Oh yes, and one more thing. What I was doing back here, this is one of the snowballing effects of running that big square tubing instead of the channel, is it was in the way of this leg. So this leg has this on it. And this holds our tubing notcher, so that guy there. So that thing needs to bolt on and come up the side, so I did have to notch our tubing, and then I'll weld that all up, and then we'll have plenty of space. And it'll work just as intended. And that should be about it. So far, everything else is working. They did make a mistake sending us this guy. This is the center die rack, and they sent us two lefts instead of, or two. These are supposed to be opposite each other, and unfortunately we got two of the same, so this just bent the wrong way. But what we're going to do to fix that is I'm actually just going to take this off. I'm going to make both sides like this, and we'll just make that permanent in the center, because that won't be an issue anyway. The HPU mounts from the bottom, so it sits on the bottom, and then the cords and hoses run up that way and up, so it won't be an issue just having that permanent in the middle. That way we don't have to mess around with it later. Yay, we got the HPU today. It was late, our weather has not been cooperating for anything. I already failed at step one because it says to mount the thing to the cart using the brackets and the special instructions, separate instructions, so I didn't get any. So we're gonna have to figure it out. Pretty sure we can probably figure it out though. All right, so I think it's pretty safe to assume that this is gonna end up going like that. Then it's gonna go to the center bolt on the cart on the end. This is gonna obviously go to the fill hole, which is on the cart. The cords are, let's see, so these are going towards the hole. So yeah, I have the orientation down. I'm pretty sure that this is gonna go like this. Oops, I think it was the other. So since we didn't have the directions, I had to just kind of guess at one of the million options on holes. I probably could have went under there and measured and tried to figure out exactly where it went so it lined up with holes on the cart. But I just played with it, committed to the ones that I thought were the most practical, and went with it. All right, so this part is actually very self-explanatory, other than one of the hoses is longer than the other. That hose goes to port T, then you just hook it up to port T on the valve assembly up top. So I just find the balancing point of the pump with the ratchet strap and used it to do my heavy lifting. I did end up having to move that bracket. The position I chose was not correct. All right, guys, so once you plug it in, I ended up just making an adapter. Just out of another cord. I didn't have a male welding cord that fits all my outlets, and I didn't really want to buy anything because I am actually, in the future, we are going to be putting in a gantry style electrical system in the shop, and that'll end up running, they'll end up running separate different plugs. I'm going to do all twist lock plugs on that. So anyway, I just made an adapter for now. It's just a 50 amp welding cord to the 50 amp like dryer style cord that comes on the pump. So to turn it on, you just flip the switch underneath. And then, theoretically, when you actuate the pump, either the lever, either way, it hits this little micro switch, and that micro switch tells the pump to turn on. And then this valves it. So it always spins the same direction. It's not reversing the pump or anything, or the motor. It just turns the pump on one way or the other, and then the fluid just goes. So theoretically, I think if I push this forward, it's going to roll around that direction. There's going to be air in it, so we're going to have to cycle it a few times. They say if you have the cylinder perfectly vertical, you can get the air out faster, but it should come out fairly quick just with a couple cycles of it. So that's pretty smooth. So we can watch the degrees here. I had that somewhat at 0 when we started. This thing should, in one stroke, it goes a little beyond 90, I believe. Make sure we can turn that on. That's it. So we are at 95. So if you want to go farther than that, you will unbolt that. That's supposed to be a pin. They shorted me a pin. And then when I called them to tell me they shorted me the pin and a couple other things, I was like, hey, you have the HPU yet? And yeah, and so he sent me the HPU, but he never sent me a pin. But anyway, so you would just move the cylinder back to here. So you would just lock it in right here with this one, and this one's meant to break. So you just lock it in there, unpin your cylinder, run your cylinder back, pin it there, and then you can go farther than 90. That's the theory, or at least as well as I understand it. I'm not sure. Well, there are quite a few situations where you will want to run it over 90, but I think generally you probably won't have to do that. I'm just going to cycle this thing a few times and then check our fluid level. And then we're going to take our steering arm off the Safari Wagon and do our first bend with it. All right, guys, so the very first thing I'm going to bend on our bender is my arm here. So this is for the crossover steering on the Safari Wagon. It's clearing right now, but if this side droops all the way down, the angle of this increases and it hits the sway bar right there. So I need to, that's the sway bar in link that goes on there, and I can't move it up any farther or it'll hit the frame under full compression. So you always end up in these tight scenarios. So I'm going to take and I'm going to bend it. I have it turned all the way to the right now, so I'm going to mark it because I know it needs to be straight there. It's as far this way as it'll ever can go. So I'm going to bend this up, and then I'm going to bend it back down flat over here. And then while we're at it, we're going to do a couple other projects on here, but that's not relevant to the bender. So anyway, so that's what we're going to do. So I'm going to remove this, and then we'll stick that in the bender. So that is 1.5" quarter wall. All right, so the bend has to be this way. I can't bend this section of the arm, and it doesn't leave us a lot of material down here to bend. So I have a feeling on one of the bends we're only going to be able to use one of the pressure dies. We're only going to be able to use, which I'm pretty sure it'll be okay, but I would obviously rather use both pressure dies, so you have 2 dies holding one end straight as it pulls the other end around. It may not be possible though on the second bend. Okay, well, here goes nothing. Okay, here it is in there. I don't know how much I was standing in front of the camera on that. So as we bend, this is going to be bending like this. So it's basically going to be bending this up. But if you remember, when it was upside down, we wanted it to go down. So that's where we want it. So let's see where we can bend it. So we got to adjust our pointer. So that's adjustable. So we want to run the tension or the slack out of it, which is about right there. So there's 0. And now everything looks good on there. I think I'm just going to go 5 degrees twice because I don't need a lot of clearance. So let's see what 5 degrees looks like, and I might change my mind. Okay, there's 5 degrees. That bends awfully easy. For 1.5" quarter wall, that's kind of crazy. Let's take the pressure off of it. 5 degrees was not a lot, so I'm going to go ahead and do 10. Okay. So I'm basically trying to get that so it's loose so I can unpin it. And we should be able to pull this back out of there. And take a look at it and see if that's enough. So technically it goes this way. So that's going to point it down. So the bend ended up being quite a ways away from that block. Which means that when we bend it from the other way, we don't have to put this right on the line. We can actually move this block back, so that may help us. I just want to make sure that's enough of a bend before we go any further. So I'm going to go ahead and unclamp that. I'm going to take our second HD roller out, and I should be able to bend it from this direction, right at our line. So we'll get as much drop as possible that way. Okay, I think I want my clamp block right about there. That puts my mark into the die, so it should be, I have to have my mark that way of center line of the die. I think that's going to be good enough right there. So let's straighten this out and then we'll tighten it up. Well, here we go. This should. That slot came out right at 0 again, so that's good. So now we just need to go to 10 and hope for the best. Now we gotta pull it out of here. So there's a lot more technical ways of finding your bend lines by pulling measurements, and I actually have the clip, but it doesn't seem to be compatible with this guy. But it seems like it only works off that lower die, the 6-inch center line. So I gotta kind of look into that a little bit on how that would work. But I think you could put a pin through there and it wouldn't affect anything because it's in this slot. Anyway, see if I can get this out of there. Oh, I can. So that's going to work out pretty good. I'm pretty happy with that. All right, guys, so that wasn't much of a test for it. It bent that very easily. So I don't have any 1.5-inch tubing, any of that left over, so I can't bend that. But I do have 1-inch Schedule 40. Obviously, it's going to be easy, but I want to see the bend quality of it anyway. So we're going to bend some of that. And then, this is the icing on the cake. After we bend the 1-inch, we're going to see if we can't break it by bending 2-inch quarter wall, DOM. That's big. That's the biggest thing that this thing should be able to bend. So we're going to give it a shot and see if anything fails on it. So I think worst case is it's going to bend a pin on it, but that's just my guess. So anyway, let's get this thing set up for 1-inch Schedule 40. So that's pretty thin wall, 1-inch, and we'll see what it does. Okay, if this bends this, I have obviously no question that it's going to bend it. But if this bends this without deforming it very much, I'm going to be pretty happy. There. I got one upgrade I'm going to do to this thing here in a little while, and I'll show you that at the end. I gotta run to the store to get them though. Okay, ready? Here we go. So this is 1-inch Schedule 40. Let's find a good angle. Right there. I think that actually was about 90 exactly. I went to about 93, assuming it was going to rebound, and it did rebound. Might have rebounded a little bit more. You'll probably learn how much you rebound. I'm going to go to 95. Yeah, I think 95 is about the ticket. So we should be able to just push this through like that. That is actually a really nice bend. Let's see how I did just eyeballing our angle. Take it out of there. Spin it like this. We'll take our clamp off and I'll measure that angle. Let's see how close I got it. So I'm overbent, so I went too far. So I went to 95. I should have went quite a bit less than that. So we're overbent by quite a bit. So obviously it's something you're going to learn. That I wasn't doing that to use this part. I was just kind of seeing what the bend quality of it is, and it is really good. Let's go get some dial calipers, and I'm going to measure that and see how much it deformed it. Obviously it's going to be a little fatter here, but it really doesn't look like it deformed it nearly as much as I was thinking it was going to. Okay, so first, let's measure it this way. We know it's going to end up being big, but how big? So we're about 1,335. So what is this normally? 1,325. So that's not very big. So let's see how much it's shrunk going this way. Okay, so it did shrink. So we're at 1,270 almost. So 1,270 is how much it shrank. So that's still very impressive that that's all it deformed that pipe. This schedule, this is going to be a little crude. So this is about 135 or so thickness, 135 thousandths thick. So it's pretty thin wall. It's just schedule 41 inch. And it bent it. So if you want to build a go-kart and you want to do it by buying stuff at Home Depot, this might be the trick. All right, so now I'm going to set up the dies for the 2-inch. One thing different about the 2-inch is the furthest rear die, the extra die, is actually just a cradle. All right, that's a beast of a pipe. I was actually worried it was going to flip the cart over because it's really heavy. All right, here goes nothing. Got multiple cameras in case something breaks. Here goes. So the tube's stuck on the main die a little bit, but I came up with a little trick to get it out. This is probably not recommended. But it worked. I cannot feel that at all. Let's see if we can measure it. It must be a little fat, that's why it was stuck in there. So this stuff usually measures really close to 2-inch. So it's about 3 or 4 thousandths over. And now it's about 30 thousandths over. So it grew about 30 thousandths this way, which is really not a lot. And then this way, it shrunk 90 thousandths. So that is really not that bad at all. Guys, so I'm going to show you a little trick on doing pipe. This isn't obviously going to cut this. Well, I guess it would if you had a month to do it. Well, no, it probably wouldn't. It would actually run out of wheel. But it just it's just a fast way of giving you a line around it so that when you cut it, like with a porta band, you can kind of line up on your line. I do that quite a bit on different things, just so I can get a nice line all the way around it. The other thing you could do is have something that's flexible, that is flexible this way but not side to side, like thin sheet metal or a piece of banding strap. You can wrap it around, line it up, and then trace a line, but that's a really fast way. This is just an exhaust cutter. That's all it is, but it does score a pretty good line in it. So like that. So you don't, I got a little bit of a lip right at the end where it came around, but it's pretty good. Makes a pretty decent straight cut. All right, guys, so last little upgrade, pin whiz. Link to these in the description below, but it's basically just the same pin that we were using, but it has that rubber handle. So if you're wearing gloves or anything, or your hands are dirty or whatever, or they just are sore from banging them around all the time, that makes it a lot easier. So I'm not sponsored by them, but if you follow the link below, I'll get a huge kickback of probably like 10 cents or 4 cents or 2 cents. So anyway, check that out. I really like them, so I'm gonna replace all our pins with these. All right, thanks for watching. That, if you made it this far, thank you. I had a really good time building this thing. It was probably one of my favorite things I've built so far recently. It just everything worked out so well. Even I had a few hiccups, but it went pretty good. So anyway, like, subscribe, share, do all that fun stuff, help my algorithms, and then also let me know in the comments below what you thought of this video. If I should have made it shorter, sped through stuff, not sped through as much stuff, broke it into a bunch of videos, or what you think. Obviously I can't take every suggestion, but the more suggestions I get, the more I can figure this out. I am struggling with my long format videos right now. So anyway, thanks for watching. We will see you again, well, probably this week a couple times. I got a few videos coming out.